44. 43.5, 44.
When the 3 astronauts who go to the moon complete their final checklist before launch, they are ready for a 500,000-mile round trip. Their course is pre-planned and precise. And at their command, they have some of the most sophisticated devices made by man.
5, 4, 3. Ignition detected. Transmitted 5 enter. Clock start, 5 enter. Thrust okay.
At liftoff, they are guided automatically until they reach parking orbit around the Earth. A small, complex computer in the Saturn V's instrument unit directs the rocket engines. They, in turn, push the launch vehicle into its proper orbit. But the astronauts are not alone. Their position is constantly being monitored and sent to the flight controllers at Mission Control in Houston. There, computers compare their flight with the one planned and revise the flight data.
Program 12. Trajectory monitors enabled.
The updated information is sent back to the command module, where it is stored in a small computer, the brains of the Apollo guidance and navigation system. This system makes it possible for the astronauts at any point in their lunar mission to pinpoint their position. In Earth orbit, they can use their sextant. An astronaut lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine. As they leave Earth orbit and head for the moon, the astronauts are faced with another guidance problem, that of determining their attitude, or the direction the spacecraft is facing. The astronaut navigator finds a known star in the wide-angle telescope. Using a fingertip control, he changes the attitude of the spacecraft to bring the star into line. Once he has the star in position in the telescope, he moves the optical sextant. He lines the sextant up with the star and makes a reading. He must repeat the process with another known star so that he has 2 readings to give to the onboard computer. From this information, the computer determines the attitude of the spacecraft. Once the attitude is known, the 8-ball can be aligned. This device, similar to those used in airplanes, is stabilized with gyroscopes and connected directly to the computer. To the astronaut, it's the most important display next to the computer itself. When set, it becomes the primary guidance instrument in the spacecraft and is used to orient the spacecraft for the mid-course maneuvers. This information is vital to their mission, particularly for the mid-course adjustments they will have to make when their engine has to be accurately aimed for firing. To find his position in space, the navigator goes through the same kind of routine he used in orbit around the Earth. He takes a sextant sighting on a known star and on Earth's horizon. The computer, given this information, tells him where he is relative to the Earth. As the spacecraft approaches the moon, the same procedure, this time using the lunar horizon, tells him how close he is and his position in space. The 8-ball and the computer, armed with updated information from tracking facilities on Earth, direct the aiming of the spacecraft engine for retro fire to slow the craft down to orbit speed. The navigator can then determine the altitude of the orbit and the position of the spacecraft, just as he did around Earth, using a star and a lunar landmark in the command module's sextant. For the actual landing, the lunar module uses a landing radar system tied into an onboard computer to tell him where he is relative to the actual landing spot. For the liftoff and the subsequent rendezvous, another radar unit feeds the necessary information to the lunar module computer, while the astronauts keep track of the orbiting command module with a sighting device on the window. The trip back to Earth is the opposite of the trip out. Star and moon sightings give the spacecraft's position. Mid-course corrections are made in the same way, using the 8-ball and the computer. The success of the first visit by Americans to the moon depends on many things. The rocket engines must perform without fail. The spacecraft systems must all operate reliably, and the men in flight and on the ground must be dedicated and able. And a major key to this success is the Apollo guidance and navigation system, telling the astronauts where they are and how to get where they want to go.